Yesterday we talked about dealing with standard deviation and variance, which was led into from looking at mean, median, mode, box and whisker plots and outliers. Today we're going to expand that feeling of knowledge with the standard deviation and bring it into normal distribution. Now yesterday I showed you a picture of a bell curve, and that's a great example of normal distribution. And what we mean by that normal distribution is when we have an overall pattern of a large number of observations or a large amount of data that is so regular it fits under that smooth curve, that bell-shaped curve. And you can even put a histogram into there where the area under the curve, if it's a true normal distribution, the area is exactly 1. So I've just put in here some examples of normal distribution. As you can see, if we were to draw on all of these, you can get that normal curve that for the most part, obviously this one is a normal curve, and this one has it drawn in, but you've got that general idea that it follows that general curvature. Now, to show you why these ones are not normal distribution is because, as you can see from some of these, this is skewed over to the right. This one is skewed over to the left. This one here again is skewed to the right. And then as you can see, this one is way too all over the place to have any chance of being normal distribution. So when we look at that, one of the things we want to look at is how we calculate it on the standard deviation of a normal curve. So the first and third quartiles are located approximately 2/3 of a standard deviation below and above the mean. And so if we wanted to calculate it, we get the mean of our data set, and then we calculate this standard deviation with using the graphing calculator, which we're going to do, and we multiply that standard deviation times 0.67, we just round it nicely, and then we subtract it from the mean to get quartile 1, add it to the mean to get quartile 3. And so this just helps us with figuring out how our data should be separated out. Now we have something called the 68, 95, 99.7 rule, and what this means is that when we get our standard deviation, if we have a normal curve or a normal distribution, 68% of our data, 34% on either side of the mean, will fall within 1 standard deviation of that mean. 95% will fall within 2 standard deviations, and 99.7% of our data falls within 3 standard deviations. And this is good to know because if you have those outliers that fall outside of that 99.7, outside of the 3 standard deviations, then that means that you typically will have those outliers. Those are the kids that if your teacher's going to curve a test, they're the ones who ruin the curve by getting a really good score. Or those outliers that get the really bad score when everyone else is doing well. So I drew in some pictures here to kind of show you how that falls. That our 68% fall between here and here, our 95% fall between here and here, and our 99.7%. So as you can see, we've got this little tiny square triangle on either end that gets that other 0.3%. So knowing that, let's look at some examples. So our first problem we have, SAT scores typically fall within a normal distribution. A mean score is 500, and the standard deviation is 100. And we want to know what percent of scores are above 700. So what we start out with is to draw in this. Our mean will be right here down in the middle, and this is going to be your score of 500. It says that standard deviation is 100, which means that 1 standard deviation will be here. So that's 100 points above at 600 and 100 points below at 400. And from here to here is going to be that 68%. Then our 2 standard deviations falls here and here. And that would be our score of 700 and our score of 300. And 3 standard deviations, I have it drawn out here, they probably should have been stretched a little further. But when we talk 2 standard deviations, we said that from here to here should be 95% of our data. That means that 5% of our data will fall out here and here. And if it's a normal distribution, That means half on one side, half on the other. So we take our 5%, we divide it by 2 to get our half and our other half, and that means that 2.5% are above a score of 700. So now that we have this general idea of how this works, let's take a look at this problem. Now some of you are going, oh my gosh, standard deviation, haven't calculated it. What we're going to do here is we've got from 1984 to 1995, yep, all different information. We got winning scores from a golf tournament, which if you think of this like the Masters, it's over the course of 4 days, so that's why these scores look so high. And we're going to use the standard deviation in this sample and find the percent of these winning scores that fall within 1 standard deviation of the mean. Because we know that 68%, if it's a normal curve, will fall within 1 standard deviation. So the first thing we're going to do is we're going to use a graphing calculator to find the mean and standard deviation. So if you remember from yesterday, that means we're going to click on the stat button and we're going to click on edit. So I'm going to click enter, and I have all these information from yesterday in here still. So I'm going to go and write over the top of them. So I have 276 and 279, 279 again, 277, I got 278s, and then I have 280, 282, 285, 272, 279, and 278. Hit enter, and then I'm going to clear that. I'm going to clear that one out. Oops. There we go. So now we have our data in here. Now, remember, once we've got that, we need to then go back to stat, go over to calculate, one variable stats. Remember, we need to hit that enter twice. And we see that our mean is equal to 278.6, and that the standard deviation is equal to approximately 3. And so if we look at this, we'll say 278.6 right here. That means that 1 standard deviation above is going to be 278.6 plus 3. 278.6 plus 3, which means I'm going to have 281.6 above, and below I'm going to take 278.6 minus 3, so 275.6. So it says here, winning score fall within 1 standard deviation of the mean, and we want the percent. So we look here, we need something above 275.6, but below 281.6. So we have these numbers that I'm circling. So we need basically 276 all the way up to 281. So 282 is too high, 285 is too high, 272 is too low. And we look here and we have these values. So now, once we do that, we set up the curve already. And now we're going to find the percent that fall within 1 standard deviation. So we have here, as I count, 1, 2, 3, 4, 5, 6, 7, 8, 9 of them out of 10, 11, 12. So that is 75%, because that's 3/4. So this isn't a true normal distribution because of that fact that that's 75 and we need only 68. What I need you to do right now, I realize we've only done 2 examples, but I have here that 2,000 freshmen at the U of M took a biology test. The scores were distributed normally, so I'm telling you it's normal distribution, with a mean of 70 and a standard deviation of 5. So I want you to label the mean and 3 standard deviations from the mean on the graph I've given you, and then answer the following questions. And you should be able to gather that mean that you know it's a normal distribution. Please enter your answers for these questions, these 7 questions, into Edpuzzle, and bring your questions with you to class tomorrow.